Now what I'm going to do is apply the Euler method. I'm going to copy these headings. So I select those headings, those cells, Command or Control C. I'm going to click over here. In fact, I'll click one column away just to give us some space in between, and then paste. So this region here has the values computed by kinematic equations. This region over here will be the Euler method. I'm going to add columns for the acceleration for both the x and y directions. So what I'm going to do is I'm going to put the acceleration for x right in this column J. I'm going to move these labels one column to the right. To do that, I select them and then move the cursor around until it turns into a hand. Click and then drag to where I want those values or those cells to be. Now I've got a free cell here, x sub x, a sub x. I'll format that. And then I'll copy that to here, and then just rename the x to a y by adding a y and then removing the x. I'm going to take this empty column and just make it narrower, just so I can get everything in here. I want to add, though, that for very wide spreadsheets, you can also split screens left and right. As before, when the cursor turns into this two vertical lines with arrows horizontal, I can then click and drag and decide where I want the split to occur, and then I have two separate scrolling regions. To remove one of these, by the way, hover the mouse over the bar, and when it changes the mouse into a vertical line with horizontal arrows, double click, and that takes it out. Okay, now I'm not sure why I put this T column here. I don't even need that. We already have a T. This would just be redundant. So what I'm going to do is remove this column. To do so, I'm going to select the column by clicking on the letter here, and under Edit, I just select Delete. And that moved everything to the left. Okay, the x acceleration is going to be 0 for now. The y acceleration will be equal to this value from our parameter table. I'm going to put a $sign in here so I can copy that down without any problem. And for now, the y acceleration will be constant. The x acceleration will be a constant 0. The y velocity initially is equal to the initial y velocity we calculated above. The y position initially is equal to the value from above, and so on. I'll go ahead and fill in the x velocity initially, and then the x position. Notice I'm not entering $signs here because I'm not going to clone these formulas downward, so it doesn't matter. It would not hurt to put a $sign in front of the 1 here. It's just not necessary. Okay, that's for the first time t equals 0. One delta t time later, the very next one, the y velocity is going to have changed. So we calculate the y velocity by using the formula v is equal to v0 plus at. Again, this is just text I'm entering above here to show you what I'm doing. The actual Excel formula is going to start with an equal sign. V0 really refers to the time, the velocity just before this row. This is row 15, so we want the very most recent velocity in row 14. So I clicked on that value to get the cell reference, and then plus A, I'm going to take the most recent acceleration that I have, which is this one, times t. Now the t here is the time between this row and this row. It's not the t that appears here. It's the delta t between these two row values. So I need to enter delta t, and I'll put that row reference here. And here I will need a $sign to lock that 7, because we will be cloning this formula downward. Now y, we will use the formula y is equal to y0 plus vy t. Notice that we're not using the 1/2 at squared term here. In the Euler method, we don't use that. For t that's small, and that's our time step here as we head over here, our dt squared is going to be very small. So if we make dt small enough, neglecting the 1/2 at squared here will have little or no impact on the numerical value. So to enter the formula, we start with an equal sign. We take the previous value, and then we add to that the velocity. We take the most recent one times dt. Again, I need the $sign to lock that 7. Let me just make a cosmetic change here. This is y0 okay. The acceleration in the x direction is 0 for now, so I'll just clone that formula down, or that value down. Now for the the x velocity, we use the same type of formula here. Start with it equals previous value plus the most recent x acceleration times time. Actually, we don't have this acceleration yet. Let's use this one instead. Times time. Again, $sign to lock that 7. And this formula looks very much like the formula for Vy. And then finally for x, the formula is just like we had for y. So it starts with an equal sign, previous value plus the most recent velocity times delta t, not forgetting the $sign. The basic idea in this Euler method is that, I'll just type as I speak here, the new value of something is equal to the previous value, or I'll call it old value, plus slope times whatever delta we're talking about, delta t in this case.